So what happens if the area is below the x-axis? If an area lies beneath the x-axis, it will turn out to be negative when we complete the integral. However, in real life, areas cannot be negative. So if your area is negative, for example, -3, do not write -3 equals 3. Do write that your definite integral equals -3, therefore your area equals 3 square units, and you're demonstrating that you understand that an area cannot be negative in this context. So in this example, the curve in the diagram has the equation y equals x squared minus 5x plus 4, and we want to calculate the shaded area. So you can see that the curve doesn't give us the limits, so we're going to have to determine what the roots are in order to find where it crosses the x-axis, and we do that by equating our function to 0. So x squared minus 5x plus 4 equals 0. And then we're going to factorize that. So x minus 1 upon x minus 4 equals 0. And then we're going to equate each of our brackets to 0. So x minus 1 equals 0, giving us a lower limit of 1, and x minus 4 equals 0, giving us an upper limit for this curve of 4. Now we're going to set up our area integral by saying that a equals the integral of x squared minus 5x plus 4, which is our integrand, with respect to x. And our limits are 1 on the bottom and 4 on the top. We're then going to integrate each of these terms and put them in a square bracket, so we get x cubed over 3 minus 5x squared over 2 plus 4x, and we close our square bracket and we put on our limits of 4 at the top and 1 at the bottom. So now we need to find our area by finding the definite integral. So we're going to substitute in our upper limit first, and that gives us 4 cubed over 3 minus 5 times 4 squared over 2 plus 4 times 4. And we're going to take away the substitution of our lower limit, which is 1 cubed over 3 minus 5 times 1 squared over 2 plus 4 times 1. And if we evaluate that, we get a value of -9 over 2, or -4.5. Now, this is a negative value, so we need to stipulate that the area equals positive 9 over 2 square units because it's an area below the x-axis. Now, when calculating an area comprising several chunks, with some being above the x-axis and others below, it's essential to work out each area separately and then add them as the final step. If there's no diagram, then you must make a sketch of the curve to show whether the area you are working out is above or below the x-axis. So in this example, the diagram shows the graph of the function y equals 4x cubed minus 4x. And in part A, the graph crosses the x-axis at a0, which is one of its roots, and we want to find the value of a. So we can do this by equating our graph of the function to 0 to find all of the roots, and then using the graph to determine which one is likely to be the value for a. So we're going to take out a common factor of 4x upon x squared minus 1 equals 0, which we'll recognise as the difference of two squares. So we'll have 4x upon x minus 1 upon x plus 1, and that all equals 0. Now we can see from the diagram that there are 3 roots. So 4x equals 0 gives us x equals 0, which is the origin. We've got x minus 1 equals 0, so x is going to equal 1. And we've got x plus 1 equals 0, so x is going to be -1. And we can annotate these points onto our diagram. So -1, 0, and 1. And so our value for a is going to equal 1. So now that we know the value of a, we can calculate the shaded area. And you can see that the diagram has split this area into 3 different chunks, A, B, and C. And we're going to have to evaluate the definite integral or the area for each of these chunks separately. So we'll start off with working out the area for section A. And we're evaluating the definite integral of 4x cubed minus 4x with respect to x between negative 0.5 as our lower limit and 0 as our upper limit. So we need to put our square bracket in. We're going to integrate 4x cubed to x to the power of 4 and negative 4x to minus 2x squared. And our upper limit is 0 and our lower limit is negative 0.5. And we're now going to substitute those in to find our area. So we've got 0 to the power of 4 minus 2 times 0 squared. And we're going to subtract negative 0.5 to the power of 4 minus 2 times negative 0.5 all squared. And this evaluates to 0.4375 square units, which is the area of our first chunk A. Now we need to evaluate the area of B, which is underneath our x-axis. And so we anticipate that this is going to have a negative value. So we're going to integrate the same function 4x cubed minus 4x with respect to x between 0 and 1 this time. So our square bracket is going to have the same integral in it. So it's x to the power of 4 minus 2x squared. And our limits upper is 1, lower is 0. And we're then going to substitute these in to determine the value. And that's going to equal 1 to the power of 4 minus 2 times 1 squared. And we're going to subtract 0 to the power of 4 minus 2 times 0 squared. And that gives us a value of negative 1. Now remember that we need to explicitly state that the area of section B is going to be equal to a positive 1 square unit. So we've now evaluated the area of A and B, and we need to evaluate the area of section C under this curve. It's above the x-axis again, so we anticipate that this will be a positive area. And we're integrating the same function, 4x cubed minus 4x, with respect to x, and our limits this time are 1 and 2. Our square bracket remains the same, x to the power of 4 minus 2x squared, and our limits, the upper is 2, the lower is 1, so we're going to substitute in our upper limit first, which gives us 2 to the power of 4 minus 2 times 2 squared. And then we're going to subtract our lower limit substituted in, which is 1 to the power of 4 minus 2 times 1 squared. And this evaluates for an area for part C of our curve as 9 square units. And so to determine the total area, we need to add the areas of each chunk together. So the total area is going to equal our area for A of 0.4375 plus the area of B, which is 1, plus the area of C, which is 9, giving us a total area of 10.4375 square units.